Alright guys, welcome to Pre-algebra chapter 4. We're going to be talking all about factors, fractions, and exponents in this chapter and how we can use those things in real life. Now today, we're just starting off, of course, with 4.1, which is all about factors and prime factorization. What are factors and what is prime factorization? I'll show you. Alright, so the first thing we need to talk about is the definition of factor, or factors, okay? So what are factors? Well, they're numbers that can be multiplied together to get other numbers, right? So if I took 2 times 7, right, that would be 14. And so what I would say is, or I could ask is, well, what are the factors of 14? Well, 2 and 7 are two of the factors of 14. Now also, what other numbers could you multiply to get 14? Well, you could do 1 and 14. Okay, so they would still equal 14 if you multiply them together. So if I said list out the factors of 14, you'd say 1 is a factor, okay, because we used him there. 2 is a factor, he was used there. 3 is not, 4 is not, 5 is not, 6 is not, 7 is another factor. And once you get halfway to the number you're multiplying, okay, so 7 is halfway to 14, we know there's not going to be anything in between that 7 and the 14, so 14 is our last factor there. So those are the factors of 14. Alright, so I want you to pause the video and write out all the factors of 30 and play it when you're done. Alright, so I hope you got this. Well, you can multiply 1 times 30 to get 30, okay? So what I'm actually going to do is I'm going to say 1's going to be my first factor, but I know my last factor is going to be 30. Okay, because 1 times 30 get 30. Okay, now what I'm going to do is I'm going to start working towards the middle. 2 is also a factor of 30 because 2 can be multiplied by 15. All right, 3 is also a factor because he can be multiplied by 10. 4 is not a factor. 5 is a factor, and why? Well, he can be multiplied by 6. And there's no integer between 5 and 6, so we're done. So what I've done is listed out all the factors of 30. 1, 2, 3, 5, 6, 10, 15, and 30. Alright, next let's talk about prime numbers. Okay, well, what's a prime number? Well, it's a whole number, okay, so non-decimal and positive, that is greater than 1 and has only 2 whole number factors. And those 2 factors of the 2 factors of any prime number are just 1 in itself. Okay, for example, 3 is prime. Why is 3 prime? Because the only way that you could multiply 2 numbers to get 3, okay, 2 positive integers, okay, whole numbers to get 3, would be 1 times 3. Okay, 17 is a prime number because the only way to get to 17 with multiplication of 2 whole numbers is 1 times 17. Okay, you can't take 2 times anything to get 17. You can't take 2 times another whole number to get 17. Okay, it doesn't work, right? So take a minute. I want you to write out a couple of your own prime numbers, and then I want you to just check. Make sure that they are prime. Make sure you've guessed correctly or you've thought correctly, and then play the video when you're done. Okay, so couple of other prime numbers that come to mind are 23. Okay, the only way to get to 23 with multiplication of whole numbers is 1 times 23. 37 would be another prime number, and 43 would be another prime number. Alright, so now let's talk about composite numbers. Okay, so talk about prime numbers, so composite numbers are going to be whatever's left over, okay, in the realm of whole numbers at least. So a composite number is just a whole number that is greater than 1 and has more than 2 whole number factors. Okay, for example, 6 is composite. Why? Well, because I know that 1 is a factor of 6, because 1 times 6, okay, so there I have 2 factors already. 1 times 6 is 6. I also know that I can take 2 times 3 to get 6. Now there's nothing in between 2 and 3, that's a whole number. And so there I have my factors of 6. There's 1, 2, 3, 4 of them. Therefore, 6 is a composite number. What about 5 though? 5 is not composite, it's prime. Why? Because the only two whole numbers you can multiply together to get 5 are 1 and 5. You can't multiply anything else together to get 5. That's a two whole numbers. So 5 is not composite. I want you to take a second and I want you to find the factors of 32 for me and prove to me that it's composite. Play the video when you're done. Okay, well I know I can multiply 1 times 32 to get 32. Okay, I could also multiply 2 times what? 16 to get 32. Alright, I could also multiply 4 times what? 8 to get 32. And is that it? Yeah, that's it. So there you go. Those are the factors of 32, and you've just proved that it's composite because there are more than 2 factors. There's 1, 2, 3, 4, 5, 6 factors of 32. Lastly, well not lastly, we still got a little bit to do, but just note that the number 1 is not considered prime, but it's also not considered composite. Number 1 is really just number 1. Okay, he stands out there by himself. Alright, so now let's talk about prime factorization. What is prime factorization? Well, what you do when you factorize primely or primely factorize a number is you're going to write that number as the product, okay, so the product means multiplication, of prime numbers, okay, so prime numbers, so writing multiplication of prime numbers, okay, so how do we do that? Well, let's take the number 630, okay. 630, is that prime? No, because it's an even number and it's not 2, okay, so 2 is the only even number that's not prime, so definitely not prime, right? And we know that if we're going to write the prime factorization, that we're going to have some multiplication. So this number is going to turn, 630 is going to turn into some number times another number times another number times another number times another number, so on and so forth. I don't know how many exactly there's going to be yet, but we also know that all these numbers that are going to be multiplied together are going to be what? Prime. Okay, so if I were to write the prime factorization of 630, there's a couple ways I can do this. Okay, there's a number of ways. 630, well, let's see, 630, what can I divide 630 by? Well, I can definitely divide it by 10. Okay, so what I'm going to do is I'm going to branch this out, and what I'm using here is called a factor tree. So a factor tree is used to write the prime factorization. And I'm going to rewrite 630 as 63 times 10. Okay, so you can put a little multiplication symbol between those two. Okay, so everything's equal. This lower level of the tree is equal to that upper level of the tree, right? 63 times 10 is 630. Now I'm going to take one branch at a time here. I know that I could also take 63 and rewrite him as, well, let's see, 9 times 7 is 63. All right. Now, notice that I have a 9 here now and a 7 here. I can rewrite 9 as 3 times 3, right? Now, can I write 3 as something else times something else? No, I can't, right? I now have my prime numbers. So what I'm going to do is I'm going to circle that 3, and I'm going to circle that 3. Now let's rewrite 7. But, oh, we can't, right? I can't write 7 as 2 times 3.5 because on a factor tree, I am writing out only factors. And we remember that factors are whole numbers. So I am done with that 7, so I'm going to circle him. Now I'm going to come back to this 10, all right? And I'm going to rewrite 10 as 2 times 5, right? 2 times 5 equals 10. And what I can also do is write a little multiplication symbol in between these two, all right? Now, just before we move on, remember I said that this level of the tree is equal to that level of the tree because 63 times 10 is 630. Take 9 times 7 times 2 times 5 and see what you get in your calculator. So take a minute and do that. And if you take 9 times 7 times 2 times 5, this right there, you will see that it equals 630. So each level of the tree is equal to all the other levels. It's just written in different ways, right? Now, what do we notice about these two numbers here? Well, they're both what? They're both prime. I can't rewrite 2 as the multiplication of 2 other numbers, so I'm done with him. I also can't rewrite 5 as the multiplication of 2 other whole numbers, so I'm done with him as well. So what do I have here? Well, I actually have my prime factorization. And if I'm going to write the prime factorization of 630, I'm going to rewrite all these circled numbers in numerical order. Okay, so I'm going to rewrite it as 2 came first because it's the smallest. Then I have a 3. So I'll mark these out as I go. I got that 3. I have another 3 times, let's see, what's next? I got a 5. And then lastly, I've got times the 7. All right, let's check our work. Take 2 times 3 times 3 times 5 times 7. That equals 630. I know I've done it correctly. Now, I can also rewrite this, and probably it's better to rewrite this as 2 times, instead of 3 times 3, I'm going to rewrite that as 3 squared times 5 times 7, and I would call that done. And there you go. That's how you write the prime factorization of 630. Now, it is possible for me to do this a different way, but I would also get the same answer. So if I was going to rewrite the prime factorization of 630 a different way, well, I could start out by saying, instead of doing 63 times 10, why don't we do 30 times 21? And I could break that up and break that up, but at the end of the day, I would get the same answer as I did there, and either way is fine. All right, so this one I want you to take a second, and I want you to try on your own. I want you to write the prime factorization of 56. Play the video when you're done. All right, so remember, writing prime factorization means you need to do a factor tree. All right, so 56. What two numbers could I multiply together to get 56 that are whole numbers? Well, I don't know. Let's just start with 2. Okay, so 2 times what would get you 56? Well, 2 times 25 would get you 50. So how about 2 times 28? All right. Now 2 is prime, so I'm going to circle him because I'm done. Now how about 28 though? Well, let's see. 4 times 7 would get me 28. I know 7's prime, but 4 is not. 2 times 2. Multiplication there. 2 times 2. All right, that's 4. And both 2 and 2, well, they're the same number, and they're both prime. So I'm done. So what do I do in this case? Well, remember, I'm going to write out all the circled numbers as multiplication or in product form. So I got a 2 times a 2 times a 2 times a 7. And remember, I'm going to rewrite these instead of 2 times 2 times 2, and write it as 2 cubed times 7, and I'm done. Now, what type of number is 56? Is it prime or composite? Well, again, it's composite, right? Because there's more than one factor that multiply together to get you to what? 56. All right, so now let's talk about monomials and factoring them. Okay, so what is a monomial? Well, a monomial is a number, a variable, or the product, okay, multiplication, of a number and one or more variables. Okay, and any exponents in a monomial must be a whole number in order for it actually to be called a monomial. Okay, so for example, 4, that's a monomial. Why? Well, it's a number. Okay, x, well, that's a monomial because it's a variable. And the product of a number or one or more variables, 3x would be a monomial because it's the product of a number and one or more variables. You could also have 7x, y, z. Again, the same reason, product, okay, so 7x, y, z really means 7 times x times y times z. Also, though, you could have 28x, y squared, okay? And is this still a monomial? Well, yeah, because any exponents in a monomial must be whole numbers. So these are all examples of monomials, okay? Now, how do you factor a monomial, though? Well, let's talk about that. Factoring monomials. So let's take this last one, 28xy squared. If I was going to factor that, what would I do? Well, when factoring monomials, first, okay, what you need to do is you need to write the prime factorization of the number part first, okay? So let's take the number part of this, which is 28, okay? How do I write the prime factorization? Remember, I use a factor, what? Tree, okay? So factor tree, you start with 2 branches. Let's see, 4 times 7 is 28. Now, I know 7 is prime, so I can circle him, I'm done, but 4 is not. I can break him up into 2 times 2. Now I have all prime numbers that are circled. And so the prime factorization is 2 times 2 times 7. And really, I should write that as those become 2 squared times 7. Okay, so I'm partway done. But what comes next? Well, let's see. Still haven't dealt with the variable part yet. Okay, so that part. Now, how do I factor that part? Well, I'm just going to write it as repeated multiplication. Okay, so I'm going to write variables as repeated multiplication. So what does that mean? Well, x, y squared really is like saying x times y squared. And I can break that up even further by saying that's like saying x times y, right? Okay, so there you go. So now you have two parts, and what do you do with those things? Well, here was the number part, here was the variable part. We're going to write all that as repeated multiplication together. So I'm going to start with the number part, 2 squared times 7 times x times y, and there you go. Now, for reasons that we're going to see later on when we talk about simplifying things using factoring, I will say that when it comes to factoring monomials, and they come with variables, okay, so like this one we had 28xy squared, I would say that instead of doing 2 squared, if you wanted to do 2 times 2, and then times 7 times x times y, so those things being in a different form, this would also be okay. All right, and you'll see later on why that'll be the case. But I would accept both of these answers. So there you go. That's how you factor monomials. And that is all I have for you today, guys. So I look forward to seeing you in class.